3 minutes. Let's see, I hear somebody saying they don't hear me. Somebody else says he is talking. Alexis, I'll let you be the judge. Is my sound volume good?
Yes, I can hear you.
Hey, we still have people rolling in, so I'll give it another couple minutes. Okay, I've got other feedback that the sound is okay, so if you don't hear me, it's probably on your end. Sorry. And my clock shows 11:01. We'll give it another 1 or 2 minutes because I still see people joining. Still people coming in. For those of you already here, welcome. Okie dokie. The little beep beeps of people joining seem to have slowed down. This is kind of like when you make popcorn in the microwave. You know, you gotta listen when the beeps stop. Uh, the show starts. I knew we got another beep. Okay, well, we'll give it another maybe 1 minute because now the beeps have accelerated again. For those of you here, welcome. Slowed down again. It's 11:03. Okay, let's go ahead and get started. So, welcome. Another beep. Welcome, I'm Mike Riddle, President and General Manager here at InCab America, and this is another in our ongoing series of webinars about fiber optics and fiber optic cable specifically. And this one is Fiber Optic Cable 101. I realized that we had talked about fiber itself, and we've talked about cables specifically, but we didn't really talk about, well, how do I know which type of cable to use for a project? And even once I've selected the type of cable, how do I get to the specific cable that I need to do exactly what I want done? So that's today's topic. Let's get to it. So first, this is a RCEP compliant presentation. So we can give you continuing education credits. This is 1 hour, and what we'll do at the end, we'll tell you how to do it. But basically, you'll get an email with a link. You take a test, and you pass the test with 70%, and you get your education credits. We'll remind you of that at the end. This does not mean that RCEP endorses any of the content in here. It just means that we meet their criteria. The course description, we're going to be talking about finding the right cable. So what your cable options are by application, transmission, distribution, substation, fiber to the home, and some special cases. And then here are the specific learning objectives that we have. We'll talk about lots of different cables in a very like a high level sense. And you know, again, one of the things I use again and again is to talk about the advantages and disadvantages of one type versus another. Okay. keep going. So we've already done the introduction and sound check, the presentation itself, 60 minutes. At the end, we'll open it up for questions. And because there are a lot of people on the presentation, let's hold questions to the end. During those questions, they need to be about the subject matter only, no business related stuff. And so now let's get going. So when you get into the world of fiber optic cables, it's easy to feel overwhelmed because there are hundreds of different design types that are available. And then within each design type, there might be hundreds more variations of it, a change in fiber count or a change in fiber type comes into play. So if I'm doing a transmission line, what's the cable I should start with? And then how do I drill down to the specific cable? So if I've decided to use a cable type like OPGW, how do I then drill down into and find the specific OPGW design that I want to use? That's the subject of today's presentation. So I decided to take the approach of doing this by application. Just seemed to be a convenient way to organize it. So we will talk about transmission projects, distribution projects, substation projects, fiber to the home, and some special cases, because each project type has its own requirements. And so there's some cables are better suited for one application versus another. So first up is transmission. In the transmission realm, you've got OPGW, you've got OPPC, you've got ADSS, you've got wrapped cable, and you've even got underground cable. So let's talk about each in this application. First up, optical ground wire. It should be somewhat obvious that it was conceptually easy for somebody to come up with the idea of replacing a conventional shield wire with an OPGW. This technology has been around 30 years, plus or minus a few years. Actually, some date the first application to the early 80s. So really, I could say 40 years. In any event, at this point, it's a proven technology. It's got excellent availability, meaning you can get it. Of course, in this post-COVID world, everything seems to take longer to get, but still, it's available. There are multiple sources for it. You've got a wide range of designs that are available to meet the specific mechanical, electrical, and optical requirements that you may have. And you can expect a service life of 40 years or more, easy. There are some disadvantages to it. It's more expensive relative to any type of dielectric cable, meaning a plastic type cable or a non-metallic cable, on the order of a factor of 2. And when you're installing it, generally you want to take an outage on a line. Now, live line installation is possible and it has been done, but especially here in the United States, there are significant safety concerns with that. You don't find as many contractors who are able to do it. So you really are back to, you need the line outages. In theory, you don't, but in reality, more often than not, you do. When I talk about those wide range of designs up here to the right, there are 3 basic design types that are used today. You got center tube designs and a stranded tube design and an aluminum pipe design. That's something that we talk about, the advantages and disadvantages of each in the OPGW Engineering 101 webinar. So for today, we're just talking about it at a high level. So in transmission applications, I say that OPGW is the standard go-to solution. But there are others. Next up is ADSS. Here too, conceptually easy to add an ADSS below the phase conductors on a transmission lines. This too is a proven technology with excellent availability and multiple sources. And this too has a wide range of designs available. As you see in the little illustration here, you've got double jacket designs with aramid for strength or single jacket designs. You've got double and single jacket designs where instead of using aramid, you use fiberglass for strength, and you can even use FRP for strength if you have a problem with rodents and squirrels. But again, the main takeaway from this is there are a lot of designs available if you want to use ADSS on a transmission line, including if there is the potential for tracking. There are tracking resistant jackets that are available. This type of cable is very economical, and its big advantage in the transmission world is that it can be installed without taking an outage. It does have some drawbacks though. Generally, your service life is going to be shorter, on the order of 20 to 30 years, in part because this type of cable is more vulnerable to damage than metallic cables. So damage from shotgun damage, birds, and squirrels. But the nature of a plastic cable in an aerial environment is that it's organic chemistry, so it doesn't like UV. So it's going to have, all else being equal, a more limited lifespan than OPGW. But it's a solid solution when OPGW cannot readily be used. There are various reasons why OPGW can't be used in some applications. One is the practical one that I talked about earlier. If you can't get an outage to get it installed, you effectively can't really use it, right? But there are parts of the United States where, because there were not a lot of lightning problems, there are high voltage transmission lines that were built without shield wires. So that's another practical problem and something that makes using OPGW on those lines more difficult. So ADSS was actually used as a solution at some utilities in the western part of the United States for that very reason. So in any event, again, a solid solution when you can't use OPGW. Next up, some of you have heard about this. Maybe this is new to some people, but optical phase conductor is an option in the transmission world. Again, you've got this concept that it's intuitive that you could replace a phase conductor with a cable that has fiber in it somehow. For the moment, we're just focusing on the concept. When you do that, that's really a variation of the OPGW design concept. And so you get a lot of the advantages of OPGW, especially the service life. So you could expect 40 plus years or more. But it turns out for OPPC that you really do get some significant disadvantages to it. In addition, same disadvantages OPGW, much higher cost. Not as many applications to date. Some international customers would probably object to this claim here and say, well, there's plenty that have been done throughout the world. But again, relative to the number of OPGW installations, I would argue that it's much more limited. And one of the reasons that it's limited is that you have to get access to the fibers, and that access is much harder because you've got these phase conductors energized at 69 kV or above, if it's a transmission application. To work with the fibers, you've got to get them separated from the metal so that they're not energized. In order to do that, you have to either use a hot enclosure or an optical isolator. And these create problems with maintenance, working with splices. And you need to consider, too, that you get a double whammy. If you use an isolator specifically, but even a hot enclosure as well, if the insulation fails, you're going to end up losing both communications and power transmission. As opposed to if an OPGW fails, you've just potentially lost only your communications. I mean, there are some circumstances where it might affect your power transmission as well, but you don't absolutely lose it. Whereas when you're working with OPPC, if you lose your enclosure system, whether it's hot or isolated, you're going to lose both. If you only replace one phase or one conductor in a bundle, you're going to have problems with coordinating sag. And last disadvantage, and it's another big one, is your operating temperature of the line gets limited to 85 degrees C. At least in the United States, most utilities are already operating phase conductors for years and years at 100 degrees C, and we see a lot of utilities working with phase conductor temperatures 125 or even 150 degrees C, especially with some of the newer conductors such as SSAC, for example, or ACSS as it's more commonly called today. The reason for this limit is it's the maximum sustained fiber temperature. So the fiber can go hotter than that for very short durations, but not on a continuous basis. So it limits your line operating temperature. So on balance, I have to say OPPD, I think, is more of a special case solution when neither OPGW nor ADSS can be used for some reason. And I think that's why it's been used more internationally, because of the nature of the power grid in certain other countries in the world. Moving on, or actually before I move on, let me talk specifically about what I meant about the splicing. So this is a hot OPPC enclosure. So you can see the phase conductor here, and you've basically, or the OPPC rather, I should say, is here coming in, and it's energized, and it goes to this splice enclosure here, right off the line. So this is a suspended version. Here's a post version. Same concept. So this enclosure and this enclosure, both of them are energized at the same operating voltage as the line. So you can't just go up there and work on it. It greatly complicates any optical maintenance that you need to do in that enclosure. The other option is to use an isolator. So here you've got an OPPC coming in and it's still energized. You go down to the structure, and at some point you remove all of the metal, go through an optical isolator, and just the fibers come out the other side. So hot here, not hot at the bottom end of the isolator, and then you can, go down to your splice enclosure and do your business. But if this fails, the isolator, like I say, you get that double whammy problem there. So now let's move on. So next up, underground cable. You know, these pictures here are going to look really similar to the ADSS cables. Basically, any kind of a duct cable can be used. You pick up a lot of advantages, the proven technology, availability, sourcing. You got a lot of designs available. To include direct buried cables that are armored. Although under a transmission line, you got to be careful about armor. If it's metal, it can pick up an induced voltage and current, but there's also non-metallic armor that's available. You've got microduct cables and blown-in types of cables. You got a lot of possibilities, and these can be installed without taking an outage. You get a good service life, again, on the order of what you see for ADSS. The disadvantages, though, are significant. First of all, a lot of people have the concept that if I put a cable underground, it's somehow protected. And in the real world, it's actually a lot more vulnerable than you think. As I put it here, backhoes outnumber tornadoes. Dig-ins are the #1 cause of failures in underground power cable systems, whether it's power cable or fiber optic cable. People just digging and being careless about it causes a lot more damage than it should. And in addition, rodents come back into play again. They get into the enclosures or the vaults that you're using and can damage the cable. So underground cable is not quite as immune from damage as one might first expect or hope for. Secondly, very high installation cost. So the cable itself is really economical, but the getting it installed is quite expensive. So in a transmission application, I consider this more of a special case solution. It might be appropriate in some cases, but not a very general solution, in my opinion. Last up for the transmission applications is wrapped cable. This type of cable is literally wrapped around an existing ground wire, but it could also be a conductor, one of the phase conductors. You use a special machine. Again, a great concept, especially as a retrofit option, right? You've got an existing line with a conventional shield wire and you want to get fiber to it. This sounds great, but unfortunately, it comes with some significant disadvantages. It has a much lower service life, maybe 10 years, and some utilities have decided that they're actually only getting 5 years out of it, and they think that's okay. I don't fully understand that thinking, but that's what they think. The reason for that is it's very vulnerable to damage, because in order to do this wrapping and keep these reel sizes manageable, the cable has to be very small and light. And that means low protection. And that means it's very vulnerable to shotguns, birds, and squirrels. Those short reel lengths also mean more splices, which means more splice loss and cost, right? Your splice points are a relatively big ticket item most of the time. There's also a tendency of the cable to bunch at midspan over time, so it tends to stretch out near the towers and kind of accumulate at the middle of the span over time. And that can lead to bending, microbends, which in turn means increased attenuation. And there are a very limited number of suppliers here for this type of cable. You just don't see it used a lot in the United States in particular, and even in the world relative to the other solutions, not so much. I consider this a use it as a last resort type solution, but I felt everybody should know about it, even though you can tell I don't care for it very much. All right, so we talked about transmission applications. Now let's talk about distribution applications. And I want to point out that in the distribution world, we'll talk about the supply zone versus the communication zone. So ADSS can be used, a typical distribution circuit, you have your phase conductors and you have a neutral lower beneath the phase conductors. So ADSS could be used above that neutral or below that neutral, or it could be used in the communication zone. In the communication zone, you also see lashed cable and optical messenger wire. You could also replace that neutral with an optical neutral wire, and we'll talk about, and underground is also thrown into the mix. We'll talk about all of these possible solutions. So ADSS, we already talked about ADSS in a transmission application. In advantages, same as what we talked about before. Disadvantages, not really any. But you do have to be cognizant about shotgun, birds, and squirrels. Now, transmission applications tend to be away from populated areas, obviously not always. And the spans are long, but the point is that they can cross terrain that is popular for hunting. And so ADSS on transmission applications, a lot of problems with damage from shotguns in particular. Birds and squirrels a close second on that. Distribution, you're more close in to habitation, less, hunting and shooting going on immediately in the vicinity, unlike in transmission lines. But again, kind of relative. So not quite as bad, but, you ought to be careful. If a circuit is going through a popular hunting area, you may want to consider another solution. But in general, for distribution applications, ADSS is the standard solution for fiber optic cable. But, you need to consider about what are you going to put it in the supply zone or the comm zone. Putting it in the supply zone, you greatly reduce your make-ready cost versus strand and lash that we'll talk about. With ADSS, you don't have to worry about grounding because you don't have a metal cable involved. In the supply zone, you're not competing against other companies for space like telecommunication companies, whereas you are in the comm zone. After you get it installed, it's low maintenance. Generally speaking, you don't have to do any kind of structural reinforcement when you put up ADSS to include guying for the cable's load itself. And the installation is pretty straightforward. Utility crews know how to work with conductors so they can work with ADSS. But if you're putting it in the supply zone, you do need power utility crews. So, kind of a higher skill set and a higher cost there. You do retain that vulnerability to shotgun damage and other forms of damage. Squirrels, you can kind of fight it against. Shotguns, not so much. And you do have to be careful about sag due to ice and wind loading. Lashed cable used in the communication region. You can use any dielectric cable that you want, including armored cable. So if you've got that problem about shotguns or squirrels, this can become a solution to use an armored cable there. Again, when you're lashing, excellent availability. The cable itself is very inexpensive. A lot of designs available. You can install it without an outage. If you're working in the communication region, you can use telco installation crews instead of power crews. And if you're lashing, you have the ability to overlash. So, you can just add a cable later if you need more fiber capacity, and you still get a good service life. But it does come with some disadvantages. With lashed cable, that metal messenger cable can add significant structural loading, and in turn, that means that you do have to do things like guying. And basically, what it boils down to is that your make-ready costs can be very high, to make the circuit capable of supporting the messenger cable, and it could be $50,000 per mile or even more. So on balance, you end up with higher installation and higher O&M cost. You've got this two-step installation that drives your cost up. So first you have to install the messenger cable, then you have to go back and lash the cable to it. And then your O&M cost is the fact that the lashing wire that's used is known to break. So it's a constant maintenance headache. Here's a picture showing a broken lashing wire. So somebody's got to go back and essentially re-lash this cable. The messenger cable is metal, so it's going to pick up an induced voltage and current, and that means you got to be cognizant of that and make sure that you ground that cable. And if you're in the communication regions, you're going to have competition for space with the telcos there. Nevertheless, lash cable, there's nothing really wrong with it. It's often a good solution. But if you ask me, I have a preference, I think you can tell, for ADSS over lashed cable. Figure 8 cable I want to throw in for consideration. Don't see a whole lot of this in the utility world. You do see quite a bit of it in other applications. A lot of departments of transportation around the United States use figure 8 cable. And one way that you can think about it, as I put up here, is pre-lashed. So essentially, the construction is you have an integrated messenger wire and a fiber optic cable integrated to it. So here's your messenger cable, here's your optical subcable, and then you've got this connecting piece to keep them together. You pick up a lot of the advantages of ADSS, especially if you use this in the communication zone. You also pick up the ability to use telco installation crews. You can overlash this cable. So actually you're picking up an advantage of a lash cable there. Because you don't have a lashing wire, you don't have broken lashing wires. You can armor this sub cable so you can protect against shotguns and squirrels. The economics of this cable are not bad, and you can get a good service life out of it. It's readily available, perhaps not as readily available compared to ADSS, but it's not so special like the wrapped cable that you find it hard to get. You should be able to get it. I didn't think to put that in the list here. But you do pick up some disadvantages if you're having to do make-ready work so that the line can support the additional loading of this messenger cable. You've got those high make-ready costs there. It'll be more expensive to install than ADSS because the shape makes it slower to string and slower to splice prep. You do have to worry about bonding that messenger cable. And if you're in the supply zone, excuse me, in the communication zone, you will have that competition. I think this is a viable solution. And so I think, it's something you ought to consider. Keep it in your cable toolbox. In the distribution world, underground cable can be used, and it's just like using it in a transmission application. So sometimes in a distribution world, sometimes it's a good solution. Another solution for distribution is to replace the neutral wire with an optical neutral wire. So again, this is sort of intuitive, but it hasn't been done a lot. So is it really that intuitive? You pick up all of the advantages of OPGW, but it does have some significant disadvantages to it. One of them is the fact it just hasn't been done a lot. I can only think of one project in the United States, and that was a number of years ago. And I think a lot of that is just because it's easier to use ADSS. It's a lot more expensive than ADSS, no surprise, like OPGW. And if you were to replace a neutral, you would need new supporting hardware and you would have to change your work practices. And so it runs into resistance from the operations people because they got to do things different. Just being realistic here. Because the overwhelming amount of neutral wire is conventional neutral wire, you would also need to consider how you would distinguish in the field between a standard neutral and an OPNW. That would be easy to do, but again, you're back to it's different, and so you have to train the operations people, right? Because after a storm or if a line goes down or some problem like that, there's a tendency to just cut cables. But you wouldn't want to do that with your OPNW because you'd be knocking out communication. So you'd have to train crews to look out for the OPNW and not cut it. And be careful with the, in particular, the tap connectors that they use on neutral wires. They would need to be a little bit different, sized or designed specifically for OPNW. And so that's going to be a change to a work process. And you would have to work with the crews to make them understand what they need to do. And again, although in theory, a neutral wire would be neutral, no voltage, no current on it, in the real world, it has some of both. And so you're back to the problem that you had with OPPC, that you have hot enclosures or needing to use an isolator. Now, because the voltage and current is so much lower than it would be on a transmission line, I would be much, much less concerned about reliability being a problem with OPNW, because basically you can way over insulate so that you're not likely to have a problem. But again, that's all in the category of different work practices. So you kind of run into some like inertia against it. So I would keep it in mind, but really more of a niche type solution. Optical messenger wire. In the communication zone, you could replace that messenger wire, plain messenger wire, with an optical version, sometimes also called a metallic aerial self-supporting cable. Really, I think they're the same thing. OPMW, though, is implying that the cable supports another, like a lash cable. You could lash over it, or maybe you could use it for that with the Hendrix spatial cable system. But mass implies kind of a standalone cable, but basically they're the same. So a lot of the same advantages as OPGW, including great resistance against shotguns and critters. You do have the ability to then overlash something to add capacity, and you would get excellent service life. But the disadvantages would be the cost. Not been done a lot to date, because again, it's usually easier to use ADSS or lashed cable. And you end up again with this thing of needing to distinguish between a conventional messenger and an optical version. But again, it's different. So it's a change to work practices. And because it's metal, you got to be concerned about induced voltages and current, and use good grounding. Another possible solution to keep in mind, probably more of a niche solution though. So next up, substations. So in general, for substations, when it comes to fiber optic cable, you've got OPGW or ADSS coming in, and then within the substation, what's most common is to use duct cable to get to or from a control house. Now, in this picture, I show the splice enclosure inside the substation. Probably the most common way it's done. Could be outside though, and then brought in again underground for one reason or another. Same with ADSS. So those duct type cables that you're using within the substation, any of the ones that we've talked about, to include ADSS itself, could be used. So you could come into a substation with an ADSS, go to a splice enclosure maybe to facilitate maintenance, but then run the same ADSS underground to get to your control house. You obviously have to plan accordingly. Your conduit size has to support it, but I'm just telling you, you don't have to go and buy a separate type of cable to use within the substation if you don't want to. The general rule is wherever you use underground cable, you can use ADSS, but the reverse is not true. So in general, you cannot use duct type cable as a self-supporting cable, but you can use self-supporting cable as a duct type cable. So all of this is very, very conventional. Oh, but before I move on to these considerations, in substations, metal armor cables are generally not used because of induced voltage and current, but there are non-metallic armored cables that you could use direct buried in a substation for better protection against rodents. Other things to consider would be microducting. That microducting can be used to add capacity to existing ducts, or to when you're installing a new duct system, to make it readily or easy to later upgrade and allow for increasing capacity. And then we're seeing newer designs that are cable designs that are specifically for sensing and data acquisitions, things that are components of the smart grid system that you hear a lot of talk about in our industry. Since I mentioned microducts, what are they? Well, as the name implies, they're really small ducts. There are different versions of it, subducts versus actually true microducts versus tube bundles. There are a lot of options here. That could be its own webinar. For now, I just want to introduce you to the concept and let you know that the underlying concept is, or the driving idea is, to make better use of available conduit space. So Continuing to move on, we'll talk about fiber to the home projects. So fiber to the home projects, you've basically got some kind of a cable to the curb, as I'll call it here. Any of the cables that we've talked about for distribution applications can be used for your fiber to the home, your backbone of the network, up to and including the curb. And what you use is really up to you based upon how you've assessed the advantages and disadvantages of the cable types and solutions that we've talked about thus far. You will have multiple fiber counts, and what the fiber counts you use is going to depend upon how you have designed your network. So what your network architecture is. And then the density of your service area is a big factor there. So we don't really need to talk about these cables anymore because we've already talked about them all. What we do need to talk about is the drop cables. So the cables that you use to go from the curb to the house or to, say, an apartment building or a business or something like that. So you've basically got two options: aerial cables and underground cables. Aerial cables, you have three options: round, flat, or often called butterfly and figure eight. And in the underground, you've got all these same three, plus you have the issue of, are you going to use conduit or just direct bury the drop cables? So we'll talk about that. So the options: flat, it's the most popular option by far. What you see here, you end up with a tube, and on either side, you have something that's providing strength, and that kind of looks like a butterfly, and hence the name butterfly. This is the most popular. 90% of the cable that we supply as drop cable is butterfly cable. It's the easiest to prep of the three options. You can readily get to the tube and to the fiber itself, and you've got widely available so-called universal hardware to support it for aerial application. Figure eight cable, basically a small version of the figure eight cable that we talked about before, is the next most popular. You see here 6 to 7% roughly of what we supply is figure eight type. We see this used more often in rural settings where you need longer spans. And in this case, though, you can buy any hardware and just kind of use it. I hate to say it that way, but that's the reality. With figure eight cable, you really need to coordinate between the hardware supplier and the cable manufacturer and get the cable manufacturer to say it's okay. Otherwise, you're asking for trouble. Not a hard requirement, but a good idea. Round cable is not very popular and as drop cable, in part because you prep it like any other round cable, and it's considered the hardest to do. Not really that hard in my humble opinion, but that's the market perception. You're capable of the longest spans with this type of cable because essentially it's a micro ADSS, and a cable supplier can design it to whatever span you specify under whatever conditions you specify. In this case, though, it's not a soft recommendation that you get the hardware blessed. It's really a hard recommendation that you do so, because otherwise you're really asking for trouble. And tonable comes up with drop cable a lot, the ability to detect the cable if it's been buried readily. And any of these cable types are capable of having that tonable capability added. And then you've got kind of a universal cable. I can use it aerially or I can put it underground. As for the trade-offs between whether I direct bury an underground drop cable or put it in conduit, obviously direct bury would be a lower overall cost. You can protect the drop cable. There are different forms of armor to do that. If you're using metal armor, though, you do have to worry about grounding. That armor can itself be used. It basically inherently makes a cable tonable. Conduit, you get higher overall cost because you have to install the conduit and pull the cable in. Although cable and conduit is a possibility there to eliminate the having to pull it in. But then you'll have issues with having enough to work with at splicing. But you could do it. The conduit provides protection for the cable, and then if something goes wrong with the cable, it makes repair or replacement faster. If you're not using armor because you put it in a conduit, you don't have to worry about grounding. You could use ADSS cable and duct, as we already talked about. You could install multiple ducts for expansion or to allow other companies to come in and lease space. And the ability specifically to use microduct is another opportunity to generate some cash for your system by allowing others to have access to the conduit system. So transmission, distribution, substation, and fiber to the home. Last up, just some special situations that come up. Sensing, the world of fiber optic sensing is exploding at the moment. There's pretty much a way of sensing anything that you could imagine, and there's a fiber optic cable to go along with it. So whatever you think of, come and talk to a fiber optic cable supplier and they'll help you out with a suitable cable. If you need to get across a lake or a river, there are submersible cables that are readily available. You know, the major cable suppliers have those available as well. And then if you want to add power, so if you need fiber and power in the same cable to power something, a sensor perhaps, or some kind of a piece of communication equipment, that too can be done. So what drives cable design? When it's OPGW, the fiber count, the fault current, and the diameter always are driving your cable design. How big it ends up being is a lot of it has to do with the metal that you need to get the fault current that you've been asked to do. Diameter requirements, in my humble opinion, shouldn't drive cable design, but they often do because a customer has been using a certain size cable, whether it was a conventional cable or another OPGW from years ago or whatever, and they want to stick with the same diameter. And of course, the fiber count itself. These things always come into play. Often you'll also see the specific sag and tension requirements that are an issue and come into play, and the design type. In particular, if a customer wants plastic buffer tubes versus stainless steel buffer tubes, this will drive a cable design. And then sometimes lightning withstand capability is an issue, or the customer has something else that they need the cable to do specifically, or some other requirement for it to meet, and that comes into play. ADSS, your fiber count is a big player, your maximum span length, and then the line voltage. The line voltage tends to drive the need for a tracking resistant jacket. Often the sag as a percent of span will come into play, and then whether or not you need rodent protection is sometimes an issue. Underground lashed or figure eight, your fiber count is usually the only thing that comes into play, but sometimes the diameter, because of if going underground, the size of the conduit could be an issue, and so diameter becomes important. Drop cables, if it's an aerial cable, the max span is an issue. If it's underground cable, do you need tonability? Drop cables are generally just some low fiber count, 2 or 4 or 6. Some customers, though, want a higher fiber count, and so sometimes that becomes a major factor. And then for the specialty cable applications, what you're trying to do specifically, whether you're going under a lake, if so, how deep, those kinds of things, the application itself drives the cable design, and then the fiber count is also an issue. So we've talked about big picture, how you pick the cable that you want. But once you've picked a cable like an OPGW, how do I get the specific OPGW that I want? And that's this closing section of the presentation. I submit that there are 3 ways to do it. Method 1, use what's been used before. Well, that's easy, right? You're not rocking the boat. If your company has already used something, everybody's used to it. If it's an aerial cable like an OPGW, you've also got the hardware selected too. And as I've talked about already, operations personnel are a factor, and they're already used to working with whatever you're using. So it's true, using what's been done before does have some disadvantages. It does have some cons though. Is that cable still really the best suited or optimal for what you're doing today? Have the needs changed? Over my career, I've constantly seen customers come in. They originally bought a 24 fiber cable, and now they want 144 fiber cable, and they want everything to be the same. But that's kind of a conflict there if you look back here, right? Because there's a reality that you need a certain amount of space to put the fibers, but you've now taken away space in order to put in fibers that would have been metal. So you end up losing strength or conductivity or both. So essentially your needs have changed. You really should revisit it. And also the cons of using what you've been doing before is that if you're blocking competition, well, you should recognize that competition tends to reduce cost and improve quality and service versus sole sourcing. So I think that's a big significant con to just doing what's always been done. But it's a valid method. Method two, use catalogs, right? There's old-fashioned print ones or online versions with tabulated data. So in this one, you select a cable based upon a key requirement, like the fiber count or a cable diameter or fault current or whatever. So I want to illustrate this concept to make a point later. So let's try finding a 48 fiber ADSS expected to be used on a 12.5 kV distribution line with spans up to 300 feet under the NESC heavy loading conditions and with 1% installation sag. 1% installation sag is very common. 48 fibers is very common. 300 feet, all of this is very reasonable. So I'm going to look at how you could do this with 3 leading suppliers. They are my competitors with information that's available on their website. I'm trying to protect their identities. So let's go. We'll start off with supplier X. You go to their main website, you see optical fiber, fiber optic cables, and some other stuff. So let's select the fiber optic cables. You then see this screen. I don't see ADSS, but I do see outdoor fiber optic cables. ADSS is used outdoors, so let's select that. Then you see this screen. Micro cables, central core, rollable ribbon cables, totally gel-free fiber optic cables, central core fiber optic cables, drop fiber optic cables, loose tube fiber optic cables, rollable ribbon fiber, okay. Loose tube fiber optic cables, ADSS is usually loose tube, so let's go with that. Step 4, I now see this screen, AccuTube armored DJ/SA rib LT cables, and a whole list here. So I don't know what to choose. I don't see anything that actually says ADSS here. Okay. But it turned out that if I hovered my cursor over that, I got additional information. So I did it so you don't have to, but you're welcome to go try this yourself. I went through each one until I found on the next to the last one, applications ADSS. So great. So I picked that one. That brought up this screen. Then I had, so we're now at step 6. I saw in the application ADSS, so aerial, so that's good. So I saw description. Okay. Then I clicked on the specification tab. Ribbon, aerial, dielectric, dry block. That not really giving me technical information here. Then downloads. Power Guide Loose Tube Fiber Optic Cables brochure. So I downloaded the brochure and I got this. I got an 8-page brochure, and on page 6, I found power guide, ADSS, loose tube cable ordering information. Okay. Now, this was the closest that I found to product specifications. And I think that I made a good faith effort here to find a cable that met my hypothetical requirements, but I don't find anything that detailed that helps me out. And I'm on step 9, according to this. But anyway, I think I said 10 steps over here, but whatever. So I give up. So I'm moving on to supplier Y. Supplier Y, you go to their main website, select your country, and then you see this. And I see a search box here. So I'll just enter ADSS. I got these 4 results. Easy span, ADSS, long span, my spans aren't that long, so I think it's the easy span. Telecommunication, cables and solution, that's too general to help me, although it does say ADSS here. Telecoms product center, ADSS, but I don't know what that is. I'm just going with this. This came up, and then I saw here you could get a data sheet. I think that's what we're looking for, so I clicked that, and that brought up a 10-page document, and on page 5, I found NESC heavy, right? That's what we wanted. Single jacket. Now, I don't know, do we want single or double? I don't really know at this point. 12 to 72 fibers. Okay, I said 48, so that's in that range. Span distance up to 330 feet. I said 300, so that ought to work. I got a cable diameter and an MRCL, maximum rated cable load, and I got an initial sag of 1.5%. But I said we wanted 1. And notice that the only technical information I have is a diameter and an MRCL. That's not enough information to do sag and tension calculations, just saying. So let's move on to supplier Z. Supplier Z, their main website, you see products, and under products, you find ADSS. So let's select that. You get these options. If you click on the information tab, you can get some more information. Basically, it boils down to do single jacket versus double jacket. Don't really know, but I can make a guess that it's single jacket. That brings me here. I can click on the specification sheet. 300 feet. I'm sorry, I get a 3-page PDF, and on page 3, I see 300 feet, 48 fibers, NESC heavy, but again, the 1.5% sag. But at least I've now got a diameter, a weight per foot, and an MRCL. Is that really enough to do sag and tension calculations? No, but at least I got something more. So I find these results unsatisfying, and I hope that you do as well. Now, I know the pushback. Well, I can just go ask the manufacturer or the local rep to tell me what I should use. And my counter to that would be, yeah, but if you were buying a car, you wouldn't go to the dealer and say, tell me what I ought to buy. You want to be involved in the process. And I think you should want to be involved in your cable selection in a more proactive role as well. That's just me. Plus, it's 2022. I submit that there ought to be a better way. And in that spirit, I offer you the configurator as method 3. The configurator, you start at the website of supplier I. It's right there, the configurator. Select it. You can find OPGW, how to select that, ADSS, and a couple other things we'll talk about later. Cable selection only. The hint will provide you additional information, and it starts off with a question. Answer the question. Is rodent protection an issue for you? If you say no, then you just, I selected no, and then went on. So the line voltage, the fiber count I want, Do I know the MR maximum rated design tension? No. So you just answer the question. So then it will tell you, it comes up with basically how it's going to determine what the maximum rated design tension, which is the same as MRCL, by the way, needs to be. You can just select the heavy loading condition that we said and the maximum span and the percent of sag that we wanted. All of these are direct inputs. You can put them in feet or meters and it will calculate the opposite. You can also do it by map or by entering the name of the closest city and state. And you can do custom loading conditions if you want to do that too. It will then come up and say, which type of ADSS do you want? And again, you get this choice between double jacket and single jacket, but there is some basic information here to give you some guidelines on what to pick. So I picked the single jacket construction, and then I get this information, loads of data. I get an overall diameter, I get a weight, I get a maximum rated design tension or MRCL, plus I get cross-sectional area modulus of elasticity information that I need to do sag and tension calculations. And if I download the full specifications, I get even more data. I mentioned already, if you go back and look at that again, you can do the same thing for OPGW. You can also do space potential calculations, which is important for determining if you need a track resistant jacket. And you can get sag and tension, actually do sag and tension calculations to get the data that you need for that. So we talked 3 ways of doing it. My conclusion is that in 2022, everyone should be able to easily verify that what you've already used is really optimal or near optimal for your projects today. If it's not, or if you're starting from fresh, you ought to easily be able to find the optimal cable that you need without using old-fashioned clunky data tables and going through multiple steps that gives you incomplete information at the end of it. And I think that you ought to be able to use this configurator or something similar to it free of charge. And oh, by the way, you actually can. So I say this is a call to action in our industry, and it not just for fiber optic cable, your insulators, your hardware, your conductor, whatever. It ought to, in today's environment, there ought to be step-by-step processes that you can do online to drive you to the optimal solution for what you need for your particular project. That's my opinion. So thank you for the presentation. So now for attending rather, and now we'll open it up to questions. Enter questions in the chat, please. Okay, let's see. I don't not sound. Okay, I do see some comments about, you know, can we share this presentation? And yeah, so here's what's going to happen. After today's webinar, you'll get a follow-up email. The follow-up email is going to have a couple of things there. One is like a survey. So tell us how we did and give us suggestions for improvement. I really take your comments and suggestions to heart. So please, you know, give me some feedback here. Secondly, I mentioned already that if you want to get professional development hours, there'll be a link there to go take the test. It's 10 questions, multiple choice, pass it with 70%, and you get the credit hours. And then third is that if you want a copy of the presentation, just respond to the email and let us know, and we'll be happy to send it to you. So I see a question here, up to which voltage level can ADSS be used? In the United States, I know that ADSS has been successfully used for years and years, like decades, on 500 kV transmission lines. I'm not going to say that you can always use it on 500 kV transmission lines, but it has been done. And it's even been done in cases where the space potential would tell you that it shouldn't be done. But there are ways to kind of fake it. And I did talk about that in my space potential webinar. So if you go on our website, yeah, let me show everybody that, how to do that. Hold on one moment. So if you go to our website, by the way, just to show you what I said in the presentation, here's that the configurator that's made available to you. In the Learning Hub, you'll find all of our webinars. So we always post the most recent one of any given topic. There are lots of topics here. And if you want to see where to use tracking resistant cable, it's this one. So it talks about how to do space potential analysis, but it also talks, how you know what cable to use where in detail. Let's see. So Alexis has posted a link that you can get. What are typical lengths of the spun type of cable? So the wrap type of cable, I take it is what you mean. What I understand is typically like 6,000 feet has been common. And, whereas OPGW is regularly installed at 20,000 feet and more. The longest I've seen is 30,000 feet in my career. Actually, it was 31,000 feet. But so you often see OPGW installed 20,000 to 25,000 feet routinely. On the order of a factor of 4, but even if it was 10,000 feet, you understand that you're potentially doubling the number of splices, but it could be two or more. So let's see, Tufik, I see, has a question. Alexis, can we make it so that Tufik can talk, actually? And then is pollution, somebody asked again about the ADSS, is pollution index to be considered with voltage to consider ADSS as a solution? The problem with using pollution is that nobody has really come out and said, well, this is the limit that you should use. And plus you would have to know, I mean, you can make a guess as to what it could be, but then how do you know in a service area what pollution you're actually getting? So there's not a hard connection there. So what I've said to people who've asked me that question is, if you're having problems with pollution on your insulators, then you're likely to have problems on your ADSS. Because the underlying mechanism is basically really similar. If your insulators are getting polluted and they're tracking, then you can expect your ADSS cable to get polluted and to track, even if it's got a tracking resistant jacket on it. So then you have to use something else, and that's something else. In my spot presentation, well, one solution would be to wash the cable, and I'm sure everybody would be thrilled about doing that. The other solution is, can you prevent the tracking by grading the electric field? And the answer to that is yes, but it's beyond the scope of today's presentation to really go into detail about that. So go watch the spot video, and you'll see what you can do, and you'll also see who you can talk to in addition to me for more information. So other questions? So let's see, pollution. It was great. Okay, how much impact does the mechanical properties of the strength members like FRP rods, up-jacketed FRP as central strength member glass airman yarns have on the overall strength or tensile strength of drop cables? Well, I mean, when you ask it that way, I gotta say it has a lot, especially for drop cables. Drop cables are relatively small, and so everything has an impact on the real overall strength of the cable, including the jacket itself. With just ADSS, usually it's your aramid or your strength element that's really giving you the strength. The center member, it's often called a strength member, but I consider that a poor use of terminology. I think of it as more of an anti-buckling element, not really contributing a lot of strength. It's really the aramid or the fiberglass yarn, or if you're using FRP rod as strength, it's that's contributing like 90% of the strength of the cable would be my off the top of my head guess. You do get some contribution from the other things, but it's some overwhelming majority is coming from whatever your strength element is, the yarn. How does the splice of the strength member impact the performance of the cable? Well, you shouldn't be splicing the strength member. So, yeah. So how do I calculate, maybe on a rule of thumb basis, fiber kilometers to cable kilometers or miles? Fiber kilometers to, well, I would just write that out, right? Because your fiber count is a factor. Most cables, the helix factor is on the order of 1.025-ish. I mean, it could be a little bit more or a little bit less, but as a rough rule of thumb, that's about correct. So and if I guess it depends on what you start with. If I started with cable kilometers, I would then multiply by the fiber count and then multiply by 1.025, and that gives me the fiber kilometers. Someone says, but IEEE 1222 refers to the pollution index. Yeah, but I can't go into that in detail today. It's just, it's like with lightning on OPGW. People talk about isochronic level, but that's not what really kills a cable. It's how much coulombs hit the cable and how often becomes another factor in terms of optical reliability. So you can talk about pollution in a general sense, but the real factor is how much is really ending up on my cable. What's my natural, and even then, what's my natural wash cycle? I could have lots of cable, lots of pollution on a cable, but if I'm regularly getting rain and it's washing or cleaning the cable, it may never cause a problem. So the two work together, and that's why I say the better surrogate or the better predictor of performance is your insulator performance, which you probably have good data on that. If you're having problems with your insulator, you're going to have problems with your ADSS. At least that's the way I would bet. Okay. Tufik had been trying to ask a question. I don't know if he was able to chat. I don't know what to do. Let's see if I can find the people. Find the people. Oh, here we go. Type a name. Tufik. Alexis, do you know how to make it available for him to talk?
I allowed his mic, but it's still muted on his side.
Oh, so Tufik, Alexis is saying it's on your side. I mean, yeah, it looks like you should be able to talk, so just unmute your mic and you can ask a question. Meanwhile, anything else? I appreciate the people saying thank you. I'm glad that you find it helpful. I really do try to make these helpful for people. So, okay, Tufik, I gotta say, kind of going once, going twice.